See, here in this video we are going to discuss about how to find center of mass of a uniform semicircular wire. Right, we want to find center of mass of a uniform, the position of center of mass of a uniform semicircular wire, say having mass m, and suppose radius r. Alright, so let's take a uniform semicircular wire. This is uniform semicircular wire having radius r and mass m. Right, so in this case, see, the radius is r, the radius is r. Say this is your center, suppose the radius is given to you, this is r. Now I told you the relation between the position of center of mass and symmetry. I told you that if the any object possesses rotational symmetry, if it is symmetric about a line, then center of mass is going to lie on that axis of symmetry. If any body is symmetric about a line, then center of mass of that object is going to lie on the axis of symmetry. So here you see that this ring, a semicircular ring, is symmetric about this line. Oh, sorry, about this line. It is symmetric about this line. So center of mass is going to lie on this line. Right. So if I take it as y-axis, and let's take this as x-axis, so center of mass is going to lie on y-axis. So the only thing which we have to find is, center of mass is going to lie on y-axis. So xcm is 0. So on y-axis, your center of mass is going to lie somewhere on this axis. So x coordinate of center of mass is 0. What you need to find is ycm. What you need to find is ycm. And what's the formula of getting ycm? It's ydm. The formula of getting ycm is ydm. Right. So what I can do is, I can take an element of this ring. Suppose I take this element, say at an angle of theta, and this is d theta. So this element is having width rd theta. So what would be dm? Dm would be m upon pi r. Pi r is the circumference of the semi ring into rd theta. So this is m upon pi d theta. And what's y? Distance of this dm from x-axis. Y is what? R sine theta. So y is r sine theta, and and your dm is m upon pi d theta. Getting a point? And theta goes from 0 to pi. So it is mr upon pi, upon dm also. I'm very sorry, I forgot to write this. So this is equal to, if I take common, mr upon pi sine theta d theta, and integral dm is m only, so m will cancel out. So this is r upon pi minus cos theta 0 to pi, that is 2r upon pi. Ycm is 2r upon pi. So the coordinates are 0, 2r upon pi. Okay, that's your position of center of mass. That's the position of center of mass. Similarly, we can use this result and find out center of mass for center of mass of semi circular disk of mass m and radius r. Alright, in this case I'll be using the previous result, the result which we have derived for this one, right? Suppose we have a disk. Let me draw the figure. Suppose we have a disk over here. So this is the disk, and let's take the coordinate axis like this. Let's call it x axis, and let's call this as y axis. Now this disk, of course I have good idea about XCM. See, this disk is symmetric about y axis. So we have already discussed that if certain object is symmetric about certain axis, then center of mass is going to lie on that axis. So center of mass will be somewhere on the y axis. So XCM is 0. What we need to find is YCM. Again, I'll try to say this disk, I'll visualize this disk as made up of an element in the form of semi-ring. Element in the form of semi-ring. Semi-ring of radius r and thickness dr. So what would be mass of this semi-ring? Mass of this semi-ring is what? Mass of this semi-ring is m upon pi r square by 2. That's the or say, instead of going to this, yes, we can do this, m upon surface area of the semi disk into area of this ring. Area of this ring is what? Pi r is the circumference into dr. So pi will cancel out. So 2mr upon r square dr. That's the mass of this semi-ring. And if I want to find center of mass, YCM, the center of mass is given by this, where y is the position of dm. So what is the position of the semi-ring? Say whenever I take whenever I use this formula mi yi by sigma mi, then see here we make use of one fact. Let me write it again. Whenever this mi is particle, yi is the position of that particle, and when this mi is a rigid body, means extended object, then yi is the position of center of mass of that rigid body. If ith particle is a particle in itself, if ith mass is a particle, then yi is the position of that particle. But if ith body is extended object, then yi is the position of the center of mass of that ith body. If ith body is extended object which has got some extension space, then yi is supposed to be the position of center of mass of that ith object. So here your dm is not a particle, dm is a ring. So y is position of center of mass of that ring. So position of center of mass of this ring is what? 2r upon pi, and this dm is this, and integral dm is capital M. So this will give you what? This will give you 4m upon pi r square r squared here, and m will be here, m will cancel out, 0 to capital R. So that comes to be 4r by 3 pi. That's your YCM. So YCM is 4r by 3 pi. So you're getting my point. For semi-disk, the center of mass is x coordinate is 0 and y coordinate 4r by 3 pi. This is 4r by 3 pi. Alright. Center of mass of the semi-disk is this. Alright. Okay. Thank you very much.